So far in our session, we have practiced finding the slope given 2 points, we've practiced identifying the y-intercept on a graph, and we've practiced just looking at equations and determining whether or not they're in slope-intercept form. In this video, we'll put it all together, and we're going to practice writing equations given 2 points. So remember that slope-intercept form looks like this: y equals mx plus b, where m tells us the slope of the equation and b tells us the y value of the y-intercept. I just wanted to take a moment to explain part of why this is such an important format for writing equations. So if you look at the example in this picture, we have y equals 2x plus 3. With this equation in this handy format, we can very quickly graph the equation. I know that it's going to pass through the point 0, 3 because 3 is my b value, right? And remember, b tells us where on the y-axis we're going to pass through the y-axis. So at the point y equals 3, the line passes over the axis. So I can plot my point 0, 3, and then remember 2 is the slope because it's in this m position, so 2 is slope. So from this y-intercept that I've graphed, I can follow the slope of the line to find other points on the line. So if I were to go up to and over 1, up to and over 1, and plot a point each time, I could plot several points on the line, and then eventually, when I had enough points, I could draw a line through them to show the graph of the equation. This is something that's really handy, and it's going to come up over and over again throughout algebra. So it's important that you understand slope-intercept form, and it's easy for you to identify the values of an equation in slope-intercept form and when an equation is in that form. So let's get into some practice, and we'll finish up our session for today. So the major takeaway that we want to be able to do is write an equation for a line in slope-intercept form when you're given 2 points. So let's say, for example, you're given the points 10, 9, and 5, 12, and you're asked to write an equation for the line passing through these 2 points. So our goal then is going to be eventually we get to a point where we have an equation that looks like this, but is specific to these points. So what's the equation of this line that passes through these points in that format? So step 1, we're going to find the slope. This is something we practiced several times in the first video. So when I'm given 2 points, I know that I can find the slope by doing y2 minus y1 over x2 minus x1. In this case, as usual, I assigned x1, y1 to be the first set of coordinates and x2, y2 to be the second set of coordinates. From there, I matched everything together and plugged it in. So for example, y2 is equal to 12. You can see that y2 I plugged in 12. And then I subtracted 9, which is y1, and so on. So simplifying from here, I find that my slope is 3 over negative 5. So that's already half of the puzzle in the slope-intercept equation. Remember, y equals mx plus b, we just found the value of m, so I can plug that in. So y equals negative 3/5 x plus b. All I have to do to finish this problem now is to figure out the value of b. So notice that we started out looking at this template that had 4 variables, right? Y, x, and b. Well, I plugged in m, and I have a value for x and y that I can plug in because they've given me 2 examples, right? They've given me this example and this example. I can pick one of these points, it doesn't matter which one, and I can plug in the x and y values, because if I plug in a y value here and an x value here, I would just have a 1 variable equation and I can solve for b. So the only thing is that if I use the x coordinate from this ordered pair, I have to use its corresponding y coordinate. So I can't use, for example, 10 and then plug in 12 as my y coordinate. That's not allowed. So I'm either going to plug in x equals 10 and y equals 9, or x equals 5 and y equals 12. In general, I just pick whichever one looks simpler. So I figured, 5 is a smaller number. This looks a little bit more straightforward. Notice that 5 is also the denominator of my slope, so it makes it a little bit easier to solve. So again, what I've done here, we found the slope. Once we found the slope, we plugged in the value of slope into our y equals mx plus b formula. Now I've picked one of my ordered pairs and I've plugged in the values for x and y. Don't get confused as far as, you see 5 and then you plug it into the first slot. So 5 is equal to x. It's important that you plug it in the right spot. And 12 is equal to y. It's important that we plug that in the right spot as well. So now I've got this one variable equation and I just need to solve for b, so I'm going to simplify. So for example, I can simplify my expression here. Negative 3/5 times 5 is just negative 3. I get 12 is equal to negative 3 plus b. If I add 3 to both sides of my equation, then I'll see that b is equal to 15. So I've solved for b, and my last step now, I know what b is, I can complete my equation. So I started out with just a template, y equals mx plus b. We found the slope and plugged that in, and in our last step we found that b was equal to 15. So the answer to this question is this equation, y equals negative 3x plus 15. Let's look at another example. Once again, we're going to write an equation for a line in slope-intercept form given these 2 points. Or you can, another way of saying it, you can see I crossed out the typo, passing through these 2 points. So we've been given these 2 points. Our goal is to write an equation for the line that they pass through, or a line that passes through those points, sorry, in this slope-intercept form. So my first step, I'm going to find the slope. So I've used my definition of slope and I've plugged in points accordingly. And we've practiced this a few more times now, so I'm not going to go quite into as much detail here. But once again, I have x1, y1, x2, y2. So I plug in my numbers accordingly and I simplify. Notice that in the denominator I ended up with a 1 minus a negative 1 because of this negative 1 value here. So I ended up with a positive 2. And when I simplified everything, I got a slope of 3. So I've found my slope. I'm going to plug that into my template for my slope-intercept form, y equals mx plus b. We just found m, so we're going to plug that in. So we're halfway there. We have y equals 3x plus b. All we have to do is figure out b, and we'll have the equation for this line. Okay, so remember, to solve for b, because we've been given x values and y values that we're told are true for this equation, we can just pick one of our ordered pairs and plug in the x and y values. So I'm going to choose this one, 1, 7. And again, you could have chosen the other point. It's really what seems more convenient for you. I decided I didn't want to mess around with negative numbers, so I picked 1, 7. So you can see that where I had a y before, I plugged in 7 because that's my y value. And where I had an x, I plugged in 1 because that's my x value. And of course, we found out that m, the slope, was equal to 3. So these are all just values I've plugged in. So I have 7 is equal to 3 times 1 plus b. And I need to figure out the value of b. So simplifying, I know that 3 times 1 is just equal to 3. So if I have this equation, 7 equals 3 plus b, I can subtract both sides by 3, and I find that b is equal to 4. So that was the last piece of the puzzle I needed. Now I can complete my equation. We had y equals 3x plus b, but now we know that b is equal to 4. So my final answer is y equals 3x plus 4. Let's finish up with one last example of this. So once again, we're going to write an equation for a line in slope-intercept form given these 2 points, negative 4, 8 and negative 2, 3. So remember, the goal is to put the equation of that line in slope-intercept form. So in order to do that, we need slope and we need intercept. What's our slope? Let's start there. So the slope Here's our slope definition, or our slope formula. And I've plugged things in. Once again, I chose x1, y1, x2, y2 like that. And you can look and compare that I plugged things in accordingly. So x2 is equal to 3, or I'm sorry, y2 is equal to 3, y1 is equal to 8. And then in the numerator, I have a negative 2, and I'm subtracting a negative 4. Make sure you don't forget the negative sign. So I'm not subtracting 4, I'm subtracting a negative 4, which means when I simplify, I end up with negative 5 over 2, because negative 2 minus a positive 4 is the same thing as saying negative 2 plus 4, right? So negative 5 over 2 is my slope. I'm going to plug in that slope now. So remember, our goal is to get an equation in this format, but I just figured out m, so I'm going to plug that in. Now I have this equation y equals negative 5 over 2x plus b, and I need to figure out what the value of b is. So because I've already been told that both of these points are true, or are solutions for this equation, I can pick one of them and plug in x and y to solve for b. So I'm going to pick negative 2, 3. And again, you can pick whichever point just you like better. I usually either pick the one that is smaller, the one that has positive values, whichever one looks easier to work with. So once again, notice that I plugged in this y value, 3. I plugged in the slope that we figured out, negative 5 over 2, so m became negative 5 over 2. And I plugged in my x value of negative 2. So now I have a number in for all of my variables except b, so I'm going to simplify and solve for b. Notice that negative 5 over 2 times a negative 2, my 2's cancel out, and I end up with a positive 5, right, because we had a negative times a negative, which is always a positive, so I end up with a positive 5. So 3 equals 5 plus b. If I subtract from both sides, I get that b is equal to negative 2. So I'm going to complete my equation now. I started out with just the general formula y equals mx plus b. We found that the slope was equal to negative 5 over 2, so we plugged that in for m. And finally, we found that b, the y value of the y-intercept, was equal to negative 2, so we plugged in negative 2. So our final answer is y equals negative 5 over 2x minus 2. So in other words, any x value and y value that satisfy this equation, that come up with a true result when we plug them in, will give us ordered pairs that fall on the graph of this line. And that's it today, guys, for slope-intercept form.